Hello, and welcome to this week's Solution Saturday. In this video, we're going to go through question 23 from the Consortium Group 2 2011 paper. Make sure to check out the other videos in the playlist for more worked solutions for this paper, and subscribe so you don't miss out on any of our other videos. ABCD is a 4-digit number. Its first digit is a quarter of its last digit. The second digit is 1 less than its first digit. When you multiply ABCD by 4, its digits appear in reverse order. None of the digits are the same. What is the number? The first thing we can do is represent the information we've been given in the question using the block method. Some of you will already be very familiar with this method from class. Let's write out our digits. A, B, C, and D, and assign blocks to them. Let's assign one block to A. From here, we can use the prompts we've been given in the question to determine how many blocks we should give to the other digits. The first prompt is that the first digit is a quarter of its last digit. This means that D must be 4 times A, so we can assign 4 blocks to D. Another key piece of information we have is that the second digit is 1 less than the first one, meaning that B is block minus 1. We have no information for digit C, so let's leave that blank for now. And finally, the last piece of information we have is that when ABCD is multiplied by 4, the answer is DCBA. Now, let's try and get some systematic trial and error in. Let's consider what would happen if a block was equal to 0. We can very quickly realize that this option is incorrect, as it would mean that the first digit was 0, making it a 3-digit number, and B would also be minus 1, which again is incorrect. Now, what if a block was equal to 1? Well, A would be 1, B would be 0, let's leave a blank space for C, and D would be 4. This is where prompt 4 multiplied by ABCD gives DCBA comes in. Let's see what would happen should we multiply our number by 4. 4 multiplied by 4 is equal to 16, so our last digit would need to be the same as A equals 6. This means that this option wouldn't work either. Let's try substituting 2 for our block, making A 2. B would be equal to 2 minus 1, which is 1. D would be equal to 4 times 2, which is 8. So our final number would be 21 blank 8. If our last digit is 8, then when we multiply the number by 4, our last digit would also have to be 2, which aligns with our rule. This option is looking promising so far. Now to find out what C is. We know that C can't be 2, 1, or 8, as none of the digits are the same. We also know that when the entire number is multiplied by 4, the final digit in place of the C must be 1. We've already figured out that we have to carry the 3 here, as 8 multiplied by 4 is equal to 32. Therefore, the product of C and 4 added to 3 needs to yield a number that has 1 as its unit digit. We can use trial and error here. The numbers we could try could be 3, 4, 5, 6, 7, 9, and 0. What you should come to is that the only number that works here is 7. So our final answer is 2,178.